Assalamualaikum and a very good morning. Thank you for joining the Asia Rocket Competition online sessions. As for today's topic is on Cansize Satellite, CanSat, presented by Dr. Muhammad Hasif bin Azami, Senior Lecturer from Faculty of Electrical Engineering from UiTM Shah. Without further ado, I would like to call upon Dr. Hasif to present on today's topic. Dr. Hasif. Thank you.
Okay, boleh dengar suara saya?
Boleh, Dr.
Boleh. So, let me share my screen first. Okay. Buat macam ni, boleh nampak ke?
Boleh, Dr.
Boleh. Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Thank you to all participating to my lecture. I think it's not too much, but I really encourage you guys to have communication, Q&A, so that we can get some answer about this concept competition. I think this fall under category 2 and 3. Okay. All right. So MRC 2025, actually this CanSat category just introduced last year, 2024. And Alhamdulillah, many students from schools and university joined to this category, and they managed to launch this CanSat using drone and also by rocket. All right. So moving on to the next slide is the contents of my presentation. By the way, if you have any question, just interrupt me, unmute your microphone, and then just ask me directly, no problem. Okay, these are the contents of my presentation today. First, it's about the MRC 2025 briefly, and then about the CanSat, I will talk about the introduction, what it's actually is the CanSat, and the system engineering, the system configuration, system design and verification, functional tests, and mission operation. Okay, all right. So, by the way, this is MRC 2025. Forgot to. All right. So MRC 2025, we have similar last year. So we have three category. One is rocket. The second is the rocket plus CanSat, and the third one is the CanSat fly by drone. So we will have the similar like last year. We have 5 launches. So for the rocket category, we have 4, and then for the CanSat category, we have only 1. And the competition date is 2 until 4 September 2025, and then same place, which is the Felka Seberang Perak. Okay, maybe some of you already joined last year, so maybe for this year you can continue or maybe upgrade what you have done previously. Okay, so a brief about the satellite size. So I would like to talk the history of the famous satellites. So here you can see the multiple size of satellite. We talk about first is Sputnik 1, which is the first satellite launched by the Russia. Right, so the size is about the beach ball, so around 2 inch. And then we have Mars Orbiter, New Horizon, Cassini Orbiter, Hubble Space Telescope, and the biggest one as for now is the International Space Station. But maybe I also need to include the latest space station from China. I'm not sure how big it is, but the ISS, the size is about the American football field, so it's very huge. Okay, so this is how we compare the satellite size. Okay, because when we talk about CanSat, it is also under the satellite category, but normally for the CanSat, we are not um, launched to space. Basically, there are several tested by American researcher to launch CanSat to space, but I think they stopped this program because the CanSat normally it only do for the educational purpose on the ground, not for the space. But the background of the satellite system is almost the same. Okay, all right. So moving on to the satellite classification. Based on the mass. So actually, the satellite is based on the mass. When we talk about satellite, we need to know how big is the mass of the satellite so that we know fall under which classification of the satellite. So, for example, here we have from the right side we have a mini satellite. Mini satellite. For example, we have EOS in 2008, launched in 2008, and then we also have our Malaysian satellite called RazaSat, which launched in 2009. 2009. Okay, and then we have microsat. So microsat, for example, we have Thai Part 1 in 1998. We have Lapan A1 in 2007. We have XSat. XSat is from Singapore. So Thai Part is from Thailand. Lapan is from Indonesia. Dewata 1 is from Philippines. And we have Tiong 1 and Uzma 1, which was launched recently, early 2025. Is there any question? No. Okay. All right. And then moving on to the nano satellite. So nano satellite here, it's fall under 1 to 10 kilogram. Okay, 1 to 10 kilogram. Here we have Psi 4. This is from Japan, launched in 2003. I believe this is the first CubeSat launched to space. They have successfully all the missions from Japan. It was the first CubeSat launched to space that got all the mission. Uh, and then we have a UiTM Set 1 launched in 2008. This is from the university. And also we have InnoSat 2 in 2018, launched by ATSD. And then we have Asian Set PG1 2023. This is launched by Angkasa X. All right. And then moving down to the Pico satellite, here Pico satellite is zero point 0.1 until 0.99 kilogram. Here we have MEMS 1A and 1B. And then uh, for the Malaysia, we have Space ND, was launched in 2023. This is the size of the satellite, was launched by a spin-off company set up from USM, Space. All right. And then we have the smallest satellite. We call it as femtosat. So femtosat in 2018, it is just a ISS experiment. The name is Sprite. It's smaller than a pack of ketchup. So very small. So I think the main purpose is just to transmit any beacon or any telemetry data. So it doesn't have any like big payload or something. And also our Malaysian company called Independence X also plan to launch this femtosat. I think the name is Gerhana Sat, if I'm not mistaken. So this is the size compared to the filling of our coins. Okay. All right. So the CanSat, which for this competition MRC 2025 is fall under the Spico satellite, but the size is actually follow the can of the soda can. So it's the mass is around 350 grams, so it's fall under Pico satellite. Okay. All right. So moving on to the Malaysian satellite. So here, I'm not sure whether you guys aware or not. So we have how many total here? Satellite launch from Malaysia, by Malaysia. So we have 9, 10, 13. So we have 13 for now, since 1996. So most of it are launched by Miasat company. So here you can see Miasat have the Miasat 1, 2, 3, 3A, 3B, and then we have our micro satellite and our mini satellite, Sat 1 and Sat 1. And then we have UiTM Sat 1, Sat 2, the latest of the Miasat satellite is Miasat 3D. So if you know, Miasat satellite is for the telecommunication satellite, so broadcasting satellite. So where we use for example, for the Astro as their main um, dia punya apa pakai dia punya service of the Miasat satellite. Okay, and then here we have Aeon Set PG1. This is the company Angkasa X launched in 2023. In the same year, we have Space ND. So from the Space In, and the latest one, Uzma Sat 1, launched in January 2025. And if I'm not mistaken, now the mass open for anyone who would like to join their company, because in the future they will have the second satellite for the government of Malaysia, right? So on the left side here, you can see I just show you about this patch, the Razasat mission patch. So in 2009, so our satellite is actually using the Falcon 1, if you know the SpaceX company. So we are the first customer for their rocket in 2009. So Radasat was launched by using Falcon 1. So these are the patch. I tried to find a patch whether it's existed or not, but it's very difficult. So you can see here ATSB who developed the satellite. Okay. Right. So now we focus towards the can size. So here is the can size of 350 milliliter soda can, which is equivalent to 350 grams. The satellite, which has satellite-like functions, such as first, we have the microcontroller. So microcontroller act as the brain of the satellite. Uh, and then we have the sensors. So the sensors could be any for the control system, if you want to measure gyro or maybe the altimeter or something. And then we can also put the actuator, and then most importantly is the radio. So for the satellite, actually you need to know that the communication between ground to the satellite is done by radio communication. We have the transceiver considered as the receiver and transmitter. So if you couldn't establish the communication between the satellite and to the ground, so actually we can say that the satellite is failed. So for the CanSat and also for the CubeSat, actually this is the main problem. I mean the main issue that the satellite failed when launched to space, right? So radio is the most important for the satellite. Okay, for the CanSat, we can launch by rocket or a balloon. For now, we have the technology of drone, so we can carry up using a drone for 350 gram is very feasible. So it can be carried up by the drone, and in 2024, we didn't release the CanSat to the ground because I think we don't have the permission, but I'm not sure for this year whether we follow the last year or maybe we will release from the drone, because it's quite interesting when you can deploy from the drone and then release by using the parachute. So actually, it's more interesting. And why we use the Canset? Firstly, the main reason is low cost, and then the project which will be less than 1 year, and then it is part of the space engineering education. So um, I'm not sure in other countries because I graduated from Japan. So for the high school student or maybe low school student, so they are practicing the satellite technology using this medium, the CanSat. So from the high school, they already learn about this satellite technology using CanSat platform. So it's quite interesting. So for the high school student can learn about this satellite technology, right? And then you can see here the icon set version 3. This is from Japan. And then here they improved the design called icon set version 6. So eventually they will keep the design updated. So that makes more interesting. Sometimes they put many sensor and payload. For example, they can put the camera or anything. But again, there are many trade-off. For example, if you want to put many payload or sensors, you will also need to take a look about the power budget and also the weight of the mass of the Canset. So there are many trade-offs need to be uh, looking forward, looking on. And then this is about the history of the Canset. So the ideas come from the Professor Bob Twiggs of Space Development Laboratory of Stanford University in the US in November 1998. So initially, the idea, the CanSat type is using these two platform. One is using the fly back, and another one is front back. So what is the difference between these two? Fly back is using the parachute. Okay, maybe in 1991, there still no technology about using drone, so they are using fly back. So now we can use the drone for the CanSat launching. And then the second one is run back by CanSat. So this is the example on the bottom side on the right of the slide. So where the when the satellite when the CanSat um, decrease the altitude, and then we will try to move to the point of target. Okay. Right. This is the initial CanSat operation concept in 1998. So professor um, have this imagination to deploy the CanSat to space. So where they put the CanSat and the rocket body, and then when it reached to the space, so it have like a tier of deployment of the CanSat. So this is how the professor imagined. And then for the rocket, this is the Aeropack model rocket, where the CanSat area is located here. Okay, so 30 centimeter is for the CanSat area. And then is the nose cone, the payload frame, the parachute, and everything. So the motor at the bottom side, right? Okay, so this is how the professor imagined in 1998. But I'm not sure whether I tried to search about the result, but I think the result was not very successful, right? Okay, so moving on to the next slide. When we talk about the satellite technology, so you need to know about the system engineering. We call it as a V diagram. So I use the reference from UNISAC handbook. UNISAC is the uh, um, university consortium in Japan. So they published a handbook where how the satellite development and the system engineering. So here you can see it consists of three parts. First is the system design, second is the verification and validation, and third one is the system engineering management. So as you can see here from the first part, the system design, so you need to design the system and then the subsystem and then the component design. And actually you need to also integrate and testing for all the system, the subsystem. When we call it as a subsystem, is for example, we have the electrical power supply, the onboard computer. That is the subsystem level. For the system level, it is we call it as the whole of the satellite. So that is the system. All right. And then the component design, component integration, and testing. So when you try to design the satellite by yourself, of course, you need to look to the overall picture for the satellite, how the satellite looks like. For example, you need to know the system requirement of the Canset. The Canset has 350 gram, and then this how the board looks like. So it needs to fit under the soda can, and then what other bus system needs to be included. So all of this thing you need to take into consideration. Okay. So it's a process of from the system design, the verification, validation, and finally the system engineering management. Okay, right. All right. Moving on to the CANSAT system configuration. Here, I can explain to you a little bit about um, the bus system inside the CANSAT, or maybe similar in the any of the satellite technology. So here we have the main is the OBC, onboard computer, or we call it as the CNDH, command and data handling. So here we have the OBC with the memory, and then we have the communication bus system. So communication bus system need to have the receiver and transmitter. So need to have both for the uplink and for the downlink. And then we also need to have the sensor. So sensor, for example, the altitude sensor, temperature sensor, the voltage sensor. And then other mission subsystem, for example, if you need to have a camera on board, so you can also do that. But again, there are many trade-offs. So you need to look into the system requirement given by the MRC. Uh, so whether it needs to have the mission or not, something like that. Okay. And then the actuator. So for example, we can have the trusted Manitoka, the motor. So for the Canset, I think this one is not necessary because the actuator is quite bulky. So it's not feasible in my opinion. So and then you also need the power system. So we call it as electrical power supply. So basically we have lipo battery or any type of battery so that it can power up the OBC, the sensors, the radio, and all the mission bus system. Okay. And then finally, you need to also think about the structure and the mechanism system. So last year, there was student design using the 3D printing, and also some students just use the soda can. So depends on you which one is more feasible in your design. All right. So moving on to the first bus system, I would say um, for the satellite, usually when I give a lecture to the students, I have this formation, easy for the student to understand. I call it as a 1-4-1. So one is the structure, okay. So another four is the electrical power supply, and then we have onboard computer, we have attitude control system, and we have communication system. So that is the four. So another one is the payload. So 1-4-1. So easy to understand. So we go to the first structure system. So structure STR of a Cansize is similar as a Cansize. 350 milliliter soda can, and the functions are whole on-board components and also deployable structures such as parachute and platform. And the materials could be aluminium or 3D printing. So it depends on you which one is feasible. And the mass between 300 to 350 gram. So let's say if you design, I think the committee of MRC will provide you the CANSAT kit. Um, and then the CanSat kit, I'm not sure when, maybe in July, if I'm not mistaken. So yeah, let's say if you design your CanSat and then when you try to measure the mass, it is less than 300 grams. So what you need to do is you need to put under you need to put any dummy mass so that it could uh, uh, the mass could be within this range 300 to 350 because if it is less than 300 um, for example if you launch and then deploy using parachute so it will take more time to the CanSat to descend to the ground so it needs to be within this mass so that's the reason why. Okay. So on the right flow chart here, design process of structure subsystem. So here, so you need to identify the requirement, configuration design, strength design, restriction of mass volume, consideration of producibility, maintainability, and interfaces among subsystem, verification by test and analysis, satisfactory of requirement and then more detailed design. Okay, so you need to know the system requirement first for the structure. So we have 141, right? I mentioned to you guys before. So you need to know all the system requirement for all 141. So for structure, you need to know. And then for the next bus system also, you need to know about the system requirements. Right? Let's say for the structure, you also need to, for example, when the can set is inside the soda can, you need to have something like a hole so that you can power up, or maybe you need to charge the battery or something. For example, you use the LiPo battery, and then you need to charge the battery. So you need to think about the whole how to charge the battery and also how to, for example, you need to program again the onboard computer or and so you need to think about that when the satellite are already in the full integration. All right. Moving on to the onboard computer or CNDH. So onboard computer control and data handling, the role and the functionality. First is the central processing unit. It's the same as the CPU function. It's the control and coordinating all the subsystems. Okay, and then the data processing. So we have from various subsystem. We have from sensors and the payload. So the OBC will process all the data to, to the OBC, and then it will pass to the radio for the downlink communication and then the command execution received from the ground station. Okay, so I think from the last year competition MRC, the CanSat is only for the downlink, if I'm not mistaken, not for the uplink. So means that any data from the CanSat downlink to the ground station, so only required for the downlink, not for the uplink from the ground station to the CanSat. So only that. Okay, and then system health monitoring, monitor perform fault detection and correction. So if let's say the satellite have some issue on the battery, so how it can turn off any of the bus system so that the only OBC will turn on. So in real satellite project, we have the many of the modes. For example, we have safety mode where the battery is very low level, so we need to turn off all the other bus system except the OBC. So OBC is the brain, so it needs to run 24/7, I would say, right? So it is the brain. So this is the Arduino Nano that we use in the MRC kit 2024, and I believe it still will be used in 2025. Let's see if you want to use other than this microcontroller Arduino Nano. For example, you want to use you want to use Raspberry Pi or other microcontroller, I think it's no problem. But again, I need to highlight the trade-off. So you need to know the size and the power consumption. So for because the Cansize is very small, so I know many of you guys wants to put many things in the CanSat, but again, this is small satellite, and then you need to know the trade-off of the bus system for the satellite. Right. So for the last year, we used this Arduino Nano because of the size and the power. And then I think the CanSat kit also included with this Arduino. So we use, I think we give to the participant two set of Arduino Nano. One is for the satellite, the CANSAT, another one is for the ground station. So the ground station also needs to use this Arduino Nano so that, and then you need to integrate with the uh, LoRa radio so that you can receive all the telemetry data, right? And moving on to the EPS, so here we have an electrical power supply. So the rule and functionality is to provide uninterrupted power to all boards can send electronics. Secondly, control the charging and discharging of the battery. Thirdly, monitor the current consumption of the load sent to OBC. So I would say EPS is the CANSAT's power source. So you need to also do some power budget. So power budget is like a table that mentioned that if you turn on the OBC, how much the power consumption in voltage, or maybe you need to be more precise so that you put the energy, how long it will turn on, so that the battery is enough when you launch the CANSAT using the drone, something like that, right? So here is an example using the 9-volt alkaline battery. So for the last year, we give to the participant a LiPo battery. So the size is quite small and the capacity is 600 milliamp hour. So I believe that it's enough for the CANSAT to be deployed using the drone, right? Okay. Moving on to the ADCS, which is Attitude Determination and Control System. So for this ADCS, so ADCS is consists of two types. First one is the passive type. Another one is the active ADCS. So for this, we use only the sensor that measure passively. First is to know the altitude, the acceleration, and then I think we don't have the gyro, if I'm not mistaken. I need to check. All right. So the rule and functionality first is to achieve mission objective, because you can imagine if the satellite is tumbling, all right, rigorously. So you need to stabilize the satellite, facing to the ground so that the data can be transmitted optimally. So that is using the active control. But I believe in 2024 MRC, I think almost all the CANSAT perfectly, store in the drone, and then should be no issue. So because it didn't deploy, right? So it just stay in the store in the drone. So you need just to know uh, what is the altitude of the campsite and what is the acceleration and etc. Secondly is to survive in the space environment for power generation and thermal control. So you can imagine if the satellite in space, so the ADCS is very important. One is because you need to face the satellite, the solar panel towards the sun to have the power generation. Let's say we have irregular beta angle of the sun, so we need to make the active control of the ADCS pointing to the sun so that it can generate the power to charge the battery on board the satellite. And then secondly, for the thermal control, so let's say the satellite is quite hot, so you need to somehow to control the satellite, so maneuver the satellite so that it can maintain the temperature on board. Okay? So mainly to know the altitude and acceleration of the campsite. So for this campsite, we just want to know the altitude and acceleration. So for the ADCS, the campsite's behavior. So we just want to know how high the drone lift up your campsite, and then how about the acceleration? Okay. All right. So the next one is the COM. All right. So the final four, right? 141. So COM is the communication subsystem. So COM is the CANSAT signal, which I mentioned before. It is the most important. First is the role of the functionality is to confirm of the CANSAT survival. So if the satellite didn't downlink any telemetry data, so we can say that the CANSAT is had something wrong, which maybe we can conclude the survival of the cancer is not it's not good. So we need to check again whether it can downlink the telemetry data. All right, and then the second is to get the telemetry data. Thirdly, to control the cancer. So I think for this, maybe we are not using for the MRC. Maybe in the future, it's more interesting. It's good to have the uplink and downlink both, right? And the last one is to get the distant information of the campsite to the ground station. All right. So because we can calculate using the radio signal to know the distant information between the campsite and the ground station. So for the comm, it consists of the radio transceiver and the antenna. Okay. So you need to really understand about the communication the basic of the communication system because for the first part is the radio, right? So the radio, and then you need to also know about the antenna, and then they have the transmit power, so the link budget and everything. So if I think it is very advisable for you guys to also tabulated the link budget, means that how many power transmit downlink to the ground station so that you can establish the communication. All right. So in this radio, it has the RSSI, which is the sensitivity indicator, so that it needs to reach, I think, near to zero. If it is higher, like minus uh, 80 or minus 100, maybe you cannot establish the communication because we have many interference, so it is quite difficult to achieve the communication. Okay, so the antenna also important. You need to know how much is the dBi of the antenna. You can use any type of antenna as long as it is fit inside the soda can, right? So here it is helical antenna, or maybe you can have a patch antenna. So you can design anything for your purpose, your system. All right. Okay. So moving on to the CAD system design and verification. So here you need to list down. I think it is advisable to write in the Excel where the first one is the system requirement, how the system achieves the objective. Secondly, how the system integrate with other bus system and the environment. For the design requirement, how the system works in the design, and then what are the parameters of the design. And finally, the verification requirement. So how to verify the system of the design of the system, what is the range of the design parameters. So in satellite development, we advise to make the RAS, we call it as RAS. It's allocation requirement allocation sheet. So it consists of these three. Okay, so you need to put in the Excel. The first column is the system requirement, second column is the design requirement, the third column is the verification requirement. So if you can make this RAS, I think your project will be more, I think, more better so that you can follow how to design and how to verify your requirements. Okay, so these are the example. Verify all the Cansize function test example. So verify all the system and design requirement, test in unit level and system integrated level. Okay, for example, you have the OBC, right? Okay, so obviously the main how you want to program and load the execution, the GPIO pin and control, power budget table, like I mentioned before for the EPS and the gyroscope sensor and for the ADCS. This is just a example for the method using the rotating table test. If you don't have, I think it's key. You can just manually rotate your gyroscope sensor to see whether the gyroscope sensor works or not. Okay. Um, Here mentioned about test in unit level and system integrated level. So I always advise my students and also last year for the participant, um, you have the four bus system, right? So let's say when you get the handset kit. So my suggestion is that you need to try to um, do the unit level test first, and then if everything okay, you can do the system integrated level. Um, how to do that? So first, the unit level, for example, you got um, the Arduino Nano. Right? So when you get the Arduino Nano, what you can do first is to try to run the basic coding, which is the Blink example, right? So for the Arduino Nano, it has the LED chip on board of the Arduino Nano. So you can upload the coding to the Arduino Nano for the Blink example. So when that can be done, so you can move forward to the other bus system. Okay, so you need to check the component one by one. Why I say that? Because if you try to integrate everything without doing the unit level test, I believe it's very difficult to track where is the bug, where is the problem, where is the issue. So you need to do the unit level test. I also practice like that since my in my project in UiTM set one. So when you got all the components, do that. I mean, you have the coding for only, for example, Arduino Nano first, and then you want to test the uh, ADCS, right? So you can try to connect into OBC with the Arduino Nano with the BME sensor or something. So you need to do all one by one, and if everything okay, so you can integrate it. Right. Okay, so these are the CANSAT mission operation profile. So here you can see from the Unisec handbook launched by Rocket. I think this is the category 2, if I'm not mistaken, for the MRC, similar. So the CANSAT is located inside the body of the rocket, and then when at the 1 kilometer altitude. So you need to deploy the parachute. with the CANSET, and then we can know the coordinate flat and long of the rocket body and the CANSET. So we have the ground station on the ground so that we can track the the body of the rocket. Okay, and then on the right side is launched by a rocket. So here it's similar what we did last year. So we put in the store in the drone. Okay, so the CANSAT is placed in the drone, and then it will fly one by one. Okay, because it's can be controlled, right? Drone can be controlled, so it's more safe compared to category two, which is launched by rocket. Because I believe last year the rocket competition category one and two, it's very I would say it's very crazy because many rocket in um, there is a many scenario for the rocket, right? But for the CanSat category three, it's more controllable because using the drone. So the participant will lock the CanSat on the drone, and then when the committee ready, so it will uh, uh, launch the drone to I think around 100 or I forgot the altitude. Okay, all right. So these are the category three CanSat. The kit, okay, soldered by the students. Okay, so you can also try to solder by yourself. I think for this competition, the MRC CanFed, I believe you need to have the skill how to solder the components using jumper and everything. Okay, so we will give several kit inside the box. I believe it has the OBC, the battery. Okay, so if I can explain here is the for the OBC. Okay, all right, and then you can see there is two uh, uh, female connector. So you can use any of these two. Why I use this? Because it can stack, right? So when you can stack, it makes more um, neat when you put inside the soda can. And then you can put the screw with the nut so that it can lock the position with the soda can. Okay. And the second one is the EPS, electrical power supply. Here we use the 600 little battery, 3.7. So here we have the power module, which it convert the 3.7 to the 5 volt line. So we will give the 5 volt line to the Arduino Nano and also to the rest of the center. And here is the switch. So the switch is just for the turn on and turn off of the system. Okay, so switch you can put any places you want to use. So I think in the Kentech kit in the box, they will provide the committee of MRC will provide just a bare of the PCB, the round shape, so that you can have a flexibility where to solder and everything. So it really tests your skill of soldering. But I was amazed for the last year competition because even for the high school student, they can solder the components very good. So I believe for this year maybe better than okay. And then this is for the third image is the ADCS where we have two sensor BMI 160 and also BMP 280. All right. So I think this one is for the acceleration accelerometer and also gyro, if not mistaken, the BMI 160. And for the BMP, this one is for the altitude. So for the altitude, we don't have exact altimeter, so we are using the temperature, the pressure data, and then we calculate using algorithm to get the um, altitude of the concept, right? Okay, and then on the right side is the radio. Okay, so the radio here we have the LoRa. So when you get the kit, most likely the antenna is not plugged here, so you need to plug the antenna to the radio. So I just want to remind you guys, when you power up the radio, uh, please connect the antenna first, because in worst condition, the radio will malfunction if you are not connecting the antenna, because the power is separated in the radio. So it is advisable to connect the antenna before you turn on the radio. Okay, right. Okay. Right. So these are the category three for the last year. You can see here where the committee of the MRC 2024, the they fly the drone with the Cansize here, and then in a dedicated altitude they will stop the drone, and then from there you need to establish the communication with the ground station. So let's say if you didn't have the communication established, so I think it's not good. So you need to establish communication. I think there is some marks for that. Okay. And for the last year, the category three, the Kansai winner here is the first one is from the SMGK Yokwan. Second one is from SMK Tinggi Batu Pahat. And the third one is Sekolah Menengah Islam Iraq Ma'atafi Safran Iraq. So you can see here most of the sekolah menengah kebangsaan, sekolah menengah, they managed to won the category three. So that's quite interesting, right? So I think that's all for my part. If you have any questions, you may ask me directly so that I can try to answer if you want. Okay. Okay kan?
Assalamualaikum.
Waalaikumsalam.
Thank you, Dr. Hasif, for the very nice
Thank
presentation.
you very much, Dr. Hussein.
Uh, all right. By the way, so I'm not focusing on your presentation most of the time. Maybe perhaps can you summarize what's the difference between this year's Canset and the previous year? Is it using exactly the same or you have modified it?
Good question, Dr. Hussein. I believe when I discussed with Farah, she said we will use the same. For example, the rubric, all the rules and regulation, we use the same. Let's see if we want to have more function about the can site. Maybe we can discuss later. But for now, it's just the same as the previous year.
Okay, clear. Thank you. I think there's a question in the chat box.
Oh, okay. How tall will the Canset be dropped from the drone? I think Farah ada data tak on this? How much is the altitude of the drone?
Okay, so for now untuk CAM, there are macam tak boleh nak dropkan the Canset from drone lagi. Probably this year akan sama dengan last year.
Okay.
Di mana kita hanya fly je untuk dapatkan data boleh read ke tak macam last year.
Okay. And the drone will be how many meter it can fly?
Saya rasa sama macam last year, max
Berapa?
dalam tak 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 ingat dah.
Eh.
Dalam 500 macam tu kot.
Oh, okay. So similar like last year. So I hope answer your question, Gilang Advansra from Indonesia. Okay, thank you. No problem. So any question? Soalan satu kat chat box. Soalan lain?
Assalamualaikum, Dr. Hasif.
Oh, Waalaikumsalam, Dr.
Yeah.
Dewi. Yeah.
Yes, okay.
Ah,
Yes, just would like to ask about one question.
ah,
Before we fly the CanSat, do
okay.
you will you do any functionality test first, or how is it?
Ah, okay. Good question, Dr. Dewi. So, yeah, I think that's a good practice where we need to do the function tests on ground. So that just like a quick functional test where you already integrate all the bus system, right? And then it's already in the soda can, and then you can also connect the ground station, similar PC also possible. And then if the satellite when you CanSat when you turn on, if it can transmit the data and your ground station can receive the data, I think it's just that will be enough. I mean, for the function test on the ground.
Okay, what about the vibration test? Do you have any vibration test for the functionality
Uh,
of it? Hmm.
I think no need about the vibration test
Oh, okay.
because I believe it's not crucial for this CanSat
Oh, okay.
because it just launched by using the drone, right? So the
Okay.
drone is quite stable. So
Stable,
I
yeah.
think yeah, compare if you want to launch by rocket category 2, maybe it's yeah, I think it's very advisable.
Oh, okay. Right. Thank you, Dr. Hasif.
Thank you, definitely. More question? Ya, adik kalau dia nak tanya soalan apa-apa pun okey je. Saya jawab. Dan nanti nak kat competition tu baru tanya. It is the experience last year. Dekat competition tu baru nak tanya. Nak tanya, wait tanya sekarang. Ada tak soalan?
Perhaps me again, Dr. Hasif.
Okay. Apa Dr. Dewi? Ya, silakan.
Sorry.
Ah,
Okay,
ah,
for the goal or the objective, so
ah,
mainly it's just to read the sensor
hmm.
data, isn't it? Just now you mentioned about the altitude, attitude, and then the
Yeah.
acceleration and gyro. That's all, yeah.
Betul. So
Okay, right. Mm-hmm.
for this, because we have also in the kit we also give the I think the SD card module and also GPS. So
Mm-hmm.
I think you need also to have a log system so that it can save all the telemetry in the SD card.
Mm-hmm.
So let's say if you cannot establish the communication,
Mm-hmm.
but the telemetry data saved in the SD card when the drone touch to the ground, and then you
Landed.
can
Okay.
just see the data saved in the SD card. Also possible for that, but yeah, of course you will have a deduct mark because no established communication, right? But at
Yeah.
least
Mhm.
the CanSat save the data inside the SD
Okay, and then is there any
card.
like for example the interface of the GUI itself? It's
Mm.
is there
So you
any
can
additional marks for that one?
yeah. That's also a good question, Dr. Dewi. I believe last year, some of the students also create the GUI on the ground station side, where they can have, I mean, for example, the altitude visible there in the PC. So it makes more interesting, and maybe you can have more marks for the for that group. Mhm.
Okay,
But I think
so
it's not compulsory.
not
At
compulsory.
least,
Right.
yeah,
Mhm.
at least you can show that the data transmit to the ground station.
The
That's all.
data transmit, but the meaning that the accuracy of the data itself is not really
Mm.
concerned in this one,
Yes,
is it?
agree.
Okay. Oh, okay, right.
Yeah.
Right.
Mhm.
All right. Thank you.
All right, no problem. Okay, I think same question with Gilang and Chra. Can send only be allowed to transmit data to the ground station or can be stored on? So yeah, similar question from Dr. Dewi. So yes, so it need to transmit to the ground station and also save in the SD card. So you need to have both. If anything happen that the communication cannot establish, at least there is a data safe in the SD card. So when you retrieve the campsite on the ground, you can show to the jury that the data is there. So I think it's a good practice so that you can verify that your system is working, but the communication is you have a trouble about the communication. But still, you can have mark for that. All right, no problem here. So I think the SD card module will be given with the SD card, micro SD card, so should be no problem. So you need to do the unit level test with the Arduino Nano. So whether it can really save any data there in the SD card, because sometimes the SD card is not working well, so you need to do the unit level test first. Okay, so when you do this CanSat project, I think especially for the student, um, they can learn many things. For example, um, for the unit level tests, you need to check one by one all the bus system, and then the tricky part is when you integrate all the bus system because we have four bus system, right? For the structure should be okay, just plug and play. But for the all the four bus system, you need to verify whether it can works when you integrate everything, right? So because of the kit, CanSat kit provided, it is like a modular. So you can also stack the the boards. Depends on you whether, for example, the DPS advisable to be on the top. Why? Because we need to have the GPS data directly facing to the sky, which is the GPS satellite, right? So it is advisable to put the very top, and the radio, the LoRa, is advisable to put the very bottom one. Why? Because you can communicate with the ground station, right? So that's the way how you place the boards because you need to be stacked, right? So you need to put in such way that it is feasible for your campsite. Okay. How would daripada Nick Adam Mukrits, how would you suggest on validating the data in flight in terms of accuracy? All right, good question, Nick Adam. For example, I can have one example of the altitude. Okay, so if you use the example of the coding of the using the BME 280, okay, BME BMP 280. So normally it will measure from the sea level, right? So I advise you to make the 0 meter when it is on the ground, and then when the height is increased, so it will plus the meters, for example, like that, because the general of the basic of the coding of the BME, BMP to a 0, it will measure from the sea level. So you need to validate that reading of the altitude. Regarding the accelerometer, as you know, there is a X, Y, Z axis of the accelerometer. So one of the axes needs to point to the ground, right? So point to the ground. So the uh, the reading need to be 9.8, right? Because of the gravity. So that's how you validate the data. And what else? For the GPS, yeah. So for GPS also you need to log the GPS signal so that it points to the location, the latitude, the lot and long of the coordinate of the Canset. So when you get the Canset kit, when you test in your school or maybe in your university, um, you need to try to turn on the GPS, and then you can validate by also check from the GPS map, Google Map, so that it need to be similar. So I think um, that it's all for validating of the flight data, right? I hope I answer your question. Ada more quiz? Okay, good. Ni ada more quiz? Menjawab ke soalan? I would love to specify my question. How would the best judges assess them? Normally kita during the competition we know, for example, the GPS, we know the coordinate of the location, so we compare the GPS data, the coordinate, and for the BMP, and also BMI 160. So usually the judges will see whether the data changes when it's transmitted to the ground station. Sometimes it didn't changes in the data, so it needs to changes. For example, when it increase the altitude, right? So so that the judges will try to look into. Right. Yeah, then. Okay. Alright. Jaga tak ada lain.
Siap.
Daripada Humaira Husna. Okay. Mungkin saya boleh. Ya, saya. Boleh. Silakan.
Waktu pembentangan, adakah
Okey.
pembentangan hanya boleh dibenarkan dalam bahasa Inggeris ataupun boleh apa-apa bahasa je?
Yang ni saya rasa dalam English if I'm not mistaken. Tapi slide tu dalam English lah. Cuma masa petang tu advisable dalam English juga kan.
Oh, alright, thank you sir.
Okey, sama. Soalan daripada Ain yang sama juga. Okay. Bukan apa sebab kita nak practice in English. Satu, satellite technology ni normally dia banyak term yang rasanya it's best to practice in English because kalau kita translate into Malay it's quite difficult lah. Alright, dan term yang dipakai pun dah very specific for the satellite technology. So if you change to Malay, mungkin ada yang faham, ada yang tak faham. So for the jury, I think lagi selesa untuk faham the term in English. Right? Okay, I hope answer question from Humaira Husna dan juga Ain soalan yang sama. Okay, sama. Alright, mungkin ada yang tengah fikir lagi soalan lain. Meanwhile, saya boleh tunjuk sikit. Okay, fine. Alright, contoh yang gambar tadi. Alright, for example, yang ni adalah Arduino Nano. Okay, so nanti akan stack, for example, so dia akan stack ni. Pakai buang ni dia dah. Okay. So dia akan staggered macam ni. Ni baru dua lah. So atas ni adalah OBC, bawah ni adalah ni apa, bateri. Right. So nanti ada banyak lagi lah. For example, ini dari ini untuk ADCS. Okay, so ADCS pun kita akan combine bawah dia dan sebagainya. So kenapa saya design macam ni? Satu, bukan saya copy lah. Exactly sebenarnya design yang dah yang tadi awal saya tunjuk daripada Japan, Unisat tu. Dia buat pun lebih kurang macam ni, cuma komponen dia pakai lain. Dan bila kita pakai macam ni, nampak dia lebih kemas. Right? So better dalam bentuk plug and play macam ni. So for example, kalau satu board ni adalah OBC, bawahnya adalah UPS. So kalau contoh OBC rosak, kita boleh betulkan. Kita tarik, kita betulkan. Right? So better like this configuration lah. Dapat di staggered. Okay. Alright. Okay. Ini apa? May I know soalan someone. May I know tips for a good report? Okay. Good report, satu, based on the first is you need to know the rubrics. I think the MRC committee will give the rubrics, so you need to follow all the requirement that provided from the rubrics. So when you have all the details, okay, maksudnya paling penting adalah system requirement, and then if you can have the power budget, link budget, everything, I think it will be a best report. Okay. So and then for the functional test, you need to include all the data, what you have done on the ground before the competition day, masuk je dalam report tu. Okay, gambar nak masuk kat situ, the serial monitor, the ground station. Okay, so kalau dah ada semua yang dia mention from the rubrics tu, saya rasa that already good. Okay. Kami menjawab someone.
Dr. Hasif?
Yes,
just following, just continuing from this question just now, about the rubric, will you share the rubric later on, or how is it for the rubric? How can you know?
I believe MRC committee akan share the rubric so that it's easier for the participant to follow lah. Kalau bukan rubrik, mungkin dia akan share rules and regulation. So daripada situ, I believe student participant easy lah untuk nak buat the report.
Okay, understood. Thank you very much.
Alright. Okay, thank you, Dr. Jen. Next question from Hira Memimpin. Kata ada edit component ke dekat Cansize tu ke sama je macam lepas? Good question from Hira Memimpin. Basically, yang saya dapat tahu daripada MRT Committee, kita akan pakai kit yang sama. So, tak ada penambahan. Mungkin kali ni apa yang kita boleh buat, kita akan evaluate mungkin lebih strict ke apa, sebab last year was the first time kan. So ada yang dapat data, ada yang tak dapat data, and mungkin ada kelonggaran sikit lah dari segi judges semua tu. Alright, so mungkin this year kita akan buat lebih more extensively untuk judging criteria supaya student lebih dapat di data downlink tu. Okay, sebab rasanya tak ramai yang dapat data downlink. Adalah banyak faktor dia kenapa. So mungkin this year kita akan tengok lebih kat situ. Baik, harap menjawab Hira Memimpin. Sebab saya percaya mungkin ada yang daripada tahun lepas dah masuk, mungkin kata tak ada tambah baik ke apa ke. So mungkin apa yang boleh buat kalau dah masuk tahun lepas, satu, you boleh improve your punya design structure ataupun you improve your punya payload. Mungkin tahun lepas tak ada kamera, mungkin tahun ni nak buat kamera. And, right. Okay, sama-sama.
Dr.
Do you
Hasif?
guys okay.
Yeah, sorry. Another question will be, just now you mentioned about the kit will be provided. For example, if we want to add another additional component, is it possible also for that one? And perhaps, let's say the antenna is not that powerful, and then we try to improve by using another type. Is it okay to rearrange the
Yes,
component?
good question, Dr. Devi. So yeah, I think it's very advisable if you want to improve all the components, because the kit is just basic things. Because I know, I mean, we have university category and also school category. So this kit actually is mainly for the school category, but for the university category, if you want to improve other components, for example, you mentioned about the antenna, so it's really a good approach to improve it. And other than that, if you want to also include the camera, it's also good for the project. But again, we just provide the basic Cansize kit. We didn't provide the other payload, the additional payload.
Okay, understood. About the additional camera, let's say just now, will it be any additional marks also if we can do something on the camera, using the camera?
Yeah, yes, good question, Dr. Dean. I think yes. We have the judging criteria where if the participant have extra payload, so it will have additional mark for that. But again, there is a trade-off, right, Dr. Devi? when you put many things inside the Cansize, you need to look for the weight, the mass of the Cansize,
Yes.
and
Yes.
also the power. So
Yes.
need to be careful on that. If it is feasible, yes, you can do it. But if not, just do the basic things so that you can have the minimum marks for that.
Okay, understood. Thank you very much.
Yeah, no problem. Um, because the Cansize is just a small platform. You can put many things inside the Cansize, but again, you need to consider all the mass, all the power, everything. So it's very interesting if you can put many things, right? But again, don't put many things. Do as simple as possible so that at least you can establish the communication. I always talk to my student or the participant. Satellite is all about the communication. If you can establish the communication, it's one step, right? And then if you can have additional payload, is another one step. So do step by step. All right. From someone for the presentation, why is it important to get A marks? I think for this presentation, at least you can show that all the functional tests, unit level and the in system integrated level you already did on the ground. I think you can have a higher mark because sometimes student didn't put the result on the presentation slide, means that they didn't finish the function test on the ground. So if you have all the function tests on the ground, make sure you put on the slide presentation so that the judges can evaluate that you already do the test. Okay? Because in experience last year, um, until the day before the competition, still the students were looking to me to uh, uh, try to check their system design whether because didn't work right. So in the presentation slide before the competition, they didn't put the function test, so they didn't get higher mark for that. Right? I hope answer the question from someone. Okay. Any other question? Someone. Lain deh. Okay. Saya tak ada soalan lah kot, Farah.
Okay, if you guys doesn't have any question, we will stop our session here. Thank you for joining us today. The attendance link I have attached at the chat box. Thank you and Assalamualaikum. Thank you, Dr. Hasif.
Sama. All the best untuk semua partisipan Cansize. Alright, insyaAllah kita jumpa.
Thank you.
Thank you, Dr. Hasif.
Sama-sama. Sama-sama.
Thank you.
Sama.